Hari Om children, welcome to Max class. Let's start our class with prayer. Sit straight, join your hands, close your eyes, chant Om 3 times. Take a deep breath. Om. 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 Om Sagana Bhavatu Saganau Bhunaktu Sahaviryam Karavavahai Tejasvinavaditamastu Mavit Vishavahai. Om Shanti Shanti Shanti. Hari Om Shri Gurubhyo Namaha. Hari Om. Learning objectives. From this class, children are going to understand about median and altitude and how to construct the centroid and orthocenter of a triangle.
To understand what medians are. Look at the triangle ABC. Assume we had point D on segment BC such that BD is equal to DC. It means D is the midpoint of segment BC. The segment BC is the side opposite the vertex A. A segment drawn from a vertex to the midpoint of its opposite side is called a median. So segment AD is one of the medians of triangle ABC. Similarly, if E is the midpoint of segment AC, then segment BE is another median of a triangle. Now we have to see if the median from point C passes through this point. So if F is a midpoint of AB, the segment CF is the last median of this triangle, and we can see that it passes through that point. We can say that all the medians are concurrent. They meet at one single point. Let's say they meet at point G. This point where all the medians of a triangle meet is called a centroid. Of all the centers of a triangle, the centroid has the most number of applications in real life. Suppose you have a pencil on which you wish to balance a triangular shaped cardboard. You will observe that there is exactly one point at which this will happen. There's only one point at which it will be balanced. And that point will be the centroid of that triangle. It will always be balanced at the centroid. This point is also referred to as the center of gravity. Basically, all the mass of this object is concentrated at this one single point. What if we want to hold that piece of cardboard using a string such that it does not tilt in any direction? Again, that will happen at just one single point, which is called the centroid. Does the centroid always lie inside the triangle? This recording from mathopenref.com will help us understand that. To change the shape and the size of the triangle, let us try moving the vertex A around. No matter where it is moved, the centroid always lies inside the triangle. Even if we try moving vertex B, it will remain inside. And it's the same case with vertex C. Actually, it is kind of intuitive if we look at our previous examples. If we want to balance the cardboard at a point which is the centroid, of course it cannot lie outside. It will always lie inside the triangle, a segment AB. How would the perpendicular bisector of this segment look? As the name says, it has to be perpendicular and it has to bisect the segment. Let line L be the perpendicular bisector of this segment and say it intersects AB at point C. This will be a right angle and length of AC will equal length of BC. The perpendicular bisector of a segment divides that segment into two equal parts and is also perpendicular to it. Let's erase this and look at perpendicular bisectors in a triangle. Consider triangle PQR. If we draw a perpendicular bisector of each side of a triangle, in all, we will have 3 of them. The angle bisectors of all the angles of a triangle always meet at a point. But do the perpendicular bisectors of the sides of a triangle also meet at a single point? Let line L be the perpendicular bisector of segment PQ. These 2 sides will be equal and this will be a right angle. Let line M be the perpendicular bisector of side QR. That will make these 2 sides equal and this angle a right angle. Now we have to see if the perpendicular bisector of segment PR passes through this point. Let line N be the perpendicular bisector of segment PR, and yes, it passes through the same point. This side will equal this side and line N will be perpendicular to PR. So even the perpendicular bisectors of the triangle meet at point C, one single point. What is this point called? It's called the circumcenter.
The centroid of a triangle is the point where the medians of the triangle intersect. The median of a triangle is a segment extending from a vertex to the midpoint of the opposite side. In order to construct the median from this vertex to this side, I'm going to need to know the midpoint of this side. And the only way that I can find that is by constructing the perpendicular bisector. Remember that when we construct the perpendicular bisector, we need to make sure that our compass is open over halfway between the 2 endpoints of the segment. Then what we do is we draw an arc below and above each of those endpoints. Now I use a ruler to connect those intersections. I'm going to draw this with a dotted line because it's not really the perpendicular line that I'm interested in. I'm just interested in this point right here because this is the midpoint. Now I'll do it for the other 2 sides as well. Now you may notice that these 3 perpendicular bisectors all intersect at this point, and this point is called the circumcenter. But the circumcenter isn't really what this video is about. It's a byproduct of constructing the perpendicular bisectors, but what we are really interested in are the 3 midpoints, here, here, and here. So now let's use our straight edge and construct our medians. Here's our first median. I'm going to use a thicker line just so that we can clearly see what the medians are and not get them confused with all of the other marks on the construction. Notice that I have gone from the vertex to the midpoint of the opposite side. And now I will draw the other 2. All 3 of the medians intersect right here at a point that we call the centroid. The centroid will always be in the interior of the triangle.
Consider a triangle ABC. If a segment AD is drawn from vertex A to its opposite side BC such that it is perpendicular to BC, then it is called an altitude. So AD is one of the altitudes of this triangle. Remember, it only has to be perpendicular to this side. D may or may not be the midpoint of segment BC. Similarly, let segment BE be the altitude from point B to segment AC. Now, if the altitude from point C to segment AB passes through this point, we can say that the altitudes of a triangle are concurrent. Let CF be the altitude to segment AB, and we can see that it passes through the point of intersection of AD and BE. all the altitudes of the triangle pass through one single point. Let's name that point O. Let's analyze this figure. Segments AD, BE and CF are the altitudes of this triangle which meet at one single point. And the point where all the altitudes meet is called the orthocenter. It's simple. We just drop perpendiculars from every vertex to its opposite side and get the orthocenter.
The orthocenter of a triangle is the point at which the altitudes of a triangle intersect. If the triangle is obtuse, the altitudes will intersect in the exterior of the triangle. To construct the altitude, we need to remember that the altitude of a triangle is the perpendicular segment from the vertex to the opposite side of that triangle. To construct the first altitude, I'm going to take the compass, put the point at the vertex, and open up the compass enough so that I can make two small arcs along this side. Now I'm going to take my compass and I'm going to put it on each of those points of intersection, and I can adjust the compass. I can open it or close it further. What has to be true is that it has to be over halfway between the two intersecting arcs. So with that in mind, I'm going to draw an arc from one side, then I'm going to draw an arc from the other side. I'm going to take my ruler and connect that vertex with that point of intersection. And this line is perpendicular to that side. Now we'll do the other two altitudes. The point where these three altitudes intersect, right here, is called the orthocenter. Now I want to show you what happens when you have an obtuse triangle. The altitude from the vertex of one of the acute angles to the opposite side is going to be a little bit tricky to construct, because if I try and draw a perpendicular from this point to the other side, notice that I'm outside of the triangle. So what we need to do is extend that side of the triangle so that I can get my altitude. Well, the first thing you need to do is extend the side. I'm just going to use a fine line, and now I'm going to do the same thing that I did in the last example. I'm going to take my compass, I'm going to mark off an arc on both sides, the compass. Now if you don't have room on your paper, you can certainly change the compass. Just make sure that it's obviously more than halfway between your two intersecting arcs. Now let's construct the other two altitudes. Notice that all three of those altitudes had to be extended to find the point at which they all intersect. This point is called the orthocenter. The orthocenter for an obtuse triangle will always be outside in the exterior of the triangle.
Children, let's recap the today's class. Centroid. The point of concurrency of the medians of a triangle is called the centroid of the triangle and is usually denoted by G. Orthocenter. The orthocenter is the point of concurrency of the altitudes of a triangle and is usually denoted by H. Learning outcomes. At the end of the class, children are learnt about the concept of median and orthocenter and construction of centroid and orthocenter of a triangle.
Hello and welcome to Yoga Eye Exercises. Lisa and Sukadev of Yoga Vidya welcome you for practice for new insights, relaxed eyes and improved eyesight. You can do this exercise standing, sitting on a chair or sitting cross-legged on the floor. Wherever you're sitting, close your eyes and feel your eyes and become aware you want to be grateful to your eyes and you want to do something good for your eyes. Open your eyes, look towards the right and towards the left, towards the right, left, right, left, right, left, right, left. Close your eyes, feel your eyes, and with each exhalation imagine you send relaxing energy, light energy from your abdomen to your eyes or through your eyes. Open your eyes again, look up, down, up, down, up, down, up, down, up, down. Close your eyes, feel your eyes, and with each exhalation send relaxing energy from your abdomen to your eyes and through your eyes. Open your eyes again. Now look to the upper right, lower left, 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 upper right, lower left. Close your eyes. Send relaxing energy to your eyes. Open your eyes again. Look towards the upper left, lower right, upper left, lower right, upper left, lower right, upper left, lower right, upper left, lower right. Close your eyes and send relaxing energy from your abdomen towards your eyes. Open your eyes again and make no circular movement clockwise. Look up and then slowly to the right and to the bottom and to the left and up to the right, down, and continue a few times. Try to make it complete circles and not just squares. This practice also helps to harmonize the two hemispheres of the brain. Now, other direction, counterclockwise. Do slow conscious movement. And slowly close your eyes and feel the relaxing energy of your abdomen go into your eyes. Now open up your eyes again and stretch out your right arm, thumb, the level of your eyes. Look towards your thumb. Look far away. Back to your thumb. Now look towards the tip of your nose, to your thumb, far away, your thumb, tip of your nose, thumb, far away, thumb, tip of your nose, thumb, far away, thumb, tip of your nose, thumb, and far away. Close your eyes, lower your hand, breathe a few times, and send relaxing energy into your eyes and through your eyes. Now, lift up your hands a little bit and rub your palms, warming up your palms and increasing the life force, the prana in your hand and your hand chakras. Put your palms over your eyes and feel the energy of your palms radiate into your eyes. Feel that calming, soothing, relaxing energy. Slowly relax your hands, lower your hands. And one more time, rub your palms, developing warmth in your palms, feeling the energy in your palms. And put your palms over your eyes and feel the relaxing energy of your palms radiate into your eyes. Slowly lower your hands. Remain seated for a few moments. Breathe a few times deeply. Feel the relaxation of your eyes, relaxation of your mind. You can do this wonderful breathing exercise every day. Your eyesight will improve. You don't need to get headache. And you come to clearer and clearer insights. Lisa and Sukadev wish you a day full of insights, full of calmness, peace and compassion.
Om Purnamata Purnamidam Purnat Purnamudachyate Purnasya Purnamataya Purnameva Vasishyate. Om Shanti Shanti Shanti.